Good day, everyone. So, what we have today is we're going to solve some optimization problem. So, our problem today is the volume of a cylinder is 900 cubic centimeter. Find the dimensions in centimeter that will minimize the surface area of our cylinder. So, the first thing we need to find is the given, what is asked, the formula. That three is the basic component how to solve a problem. So, in our surface area formula, it's given that 2 pi r squared plus 2 pi r h. So, since we have locking some numbers in here, which is h, we need first to find the volume formula, which is pi r squared multiplied by h. So, since we're given the volume, 900, so now we're going to use the formula of the volume in order for us to get the h. So, our volume is 900, which is our given, is equals to pi r squared multiplied by h. So, in order for us to do that, we need to divide both sides by pi r squared. So, it's pi r squared and 900 over pi r squared. So, next thing is cancel. So, what is remained is the 900 over pi r squared is equals to h. So that's our h, 900 over pi r squared. So now we have the h, the value of h rather. It's 900 over pi r squared. So in order for us to get the optimization equation, we need to substitute this one to the surface area formula, which is 2 pi r squared plus 2 pi r h. So now, surface area is equals to 2 pi r squared plus 2 pi r. And substitute the value of h, which is 900 over pi r squared. So the next thing we'll do is to multiply these two terms. So 2 multiplied by 900 is equals to 1,800. And 2 pi r multiplied by pi r squared is simply r, which is that one. So now we have our surface area. So this equation right here is our surface area. So now, since we get the surface area, we then get the first derivative of this equation. So the derivative of 2 pi r squared is 4 pi r. And the derivative of 1,800 over r is negative 1,800 over r squared. After that, equate the surface area into 0. So, because since we are looking for the r, we then multiply this equation by r squared. So, r squared multiplied by 4 pi r is 4 pi r cubed minus this is what minus 1,800 over r squared multiplied by r squared is 1,800 negative. So since cancel, so this is it. After that, we then transpose this equation to the other side. So this transpose negative 4 pi r cubed is equals to negative 1,800. So in order for us to have this side only remain the r cubed, so divide both sides by negative 4 pi. We then get the answer of r cubed is equals to 1,800 over 4 pi. So since we're looking only for the r, we need to cancel this cube. So in order for us to do that, we need to cube root this term. So cancel, that's why we get r. And in this one, so as the rule of this one, what we done to the other side, we need to do it on the other side also. So cube root of 1,800 over 4 pi is equals to cube root of 1,800 over 4 pi. So we then get the answer 5.23. So that's our r. So after we get the r, we then need to get the second derivative basing on the first derivative we get in our surface area, which is 4 pi r minus 1800 over r squared. So we get this equation, which is the second derivative, 4 pi plus 3600 over r cubed. So since we get now the r, we need to substitute it. So we then get this equation, 4 pi plus 3600 over 5.23 cubed. So the answer of this is 143.16 hundredths. 4 pi plus 3600 over 143.6 hundredths. So divide this and we get the answer of the second derivative, 4 pi plus 25.16 hundredths. So basing on the second derivative test, once the second derivative is greater than 0, we then conclude that the surface area is minimum. So now the dimensions that will minimize the surface area of the cylinder is at 5.23 centimeter. So I hope you learned something in our discussion today. That's all. Thank you.